Hello class, this is still the lesson for March 16, Monday. So the second lesson I'm going to teach 3.5. We're going to learn how to, we're going to learn the three theorems, okay? The first theorem is called the fundamental theorem for algebra. What this theorem tells you that if you have a polynomial, okay, this is polynomial I wrote in the class before, and it tells you this polynomial will guarantee you have at least one complex root. What's a complex root mean? It means the root contains a complex number like I, okay? So we have at least one of them. But real number also belong to complex number. That means if you just have real number, that's also okay. And number two theorems is called the complete factorization theorems. What this theorem tells you that for any polynomial, you will guarantee to able to factor, okay? A is just a number, the first number. You're able to factor like in this format. And any this number can be complex number. Number three is called zero theorem. It tells you that if you have a polynomial like this, the degree n, okay, degree n here, n is an integer, positive, as a positive integer. Okay, so let's put a plus sign here, means a positivity. It tells you that this polynomial will have n roots, means n solution. Okay, this means n solution. So this is three theorem tells you will be for what we're going to do today. So now I'm going to show you some of the example, okay, that match the one of the theorem, how we use them. So let's see some example. Be sure to do the homework as soon as you learn the lesson, and you don't want to pile them up, okay, after the when we go back to school, so we can prepare for any upcoming exam. So let's simple number 12. Okay, number 12, they want you to find all the zeros and then put the p in the factor form. Okay, so number 12, we are given p for x equal to x to 4 minus x squared minus 2. They want you to find all zeros. When they say find all zero, means that they want to solve the x. Okay, right? This one is not that hard to solve, so we don't need to use the 3.4. So all we need to do is that we're going to set this as a 0. And then we're going to factor this. So you're going to go x squared, okay, x squared, each one have a half of it. And then we go minus 2 and then plus 1. Okay, and then next thing we're going to do is set them equal to 0. And so x squared plus 1 equals 0, and then x squared minus 2 equals 0. And then we're going to subtract 1 on both sides. X squared equals minus 1. We're going to add 2 on both sides. X squared equals to 2. Now you're going to take the square root on both sides, but be careful, okay? When we take the square root on both sides, we need to put a plus minus. Plus minus, okay, don't forget. And then we will have a x equal to plus minus the square root -1, and then x equal to plus minus square root 2. Now here's what happens. Square root -1 is just I, okay? So if you guys remember, x squared plus 1 equals 0, okay? For the definition of complex number, so x squared equal to -1, and we let I equal to I squared equal to -1, okay? So when you have plus minus 1, that just equal I. And then the last one is x equal to plus minus square root 2. So that's for the first part. And for the part B, okay, they want to put the factor form. So what do they mean by that? Okay, so they want to go for like this. And you put it back inside before you solve it. Okay, so you go x plus minus I, x plus minus the square root 2. Okay, so before you solve x equal that, so they put into this format. So they want to go back to the factor form like this. Now let's try another one. Okay, let's try point number 24. Okay, point number 24. We are given a p of x equal to x third minus x squared plus x. They want to factor completely and find all the zeros, just like how we did in the first problem, except they want to factor first and find the zero. But it doesn't matter. We don't have to follow what they said. We can just solve first if you want. So we're going to take this equal to 0. And we're going to factor this one. You can see that we can take out the x squared minus x and plus 1 equals 0. Okay, and then we have x equals 0. That's the first answer. And the second answer comes from here. And by the fundamental, by the zero theorem, you know we're going to have 3 solutions because this is degree 3. So right here, okay, we couldn't factor. So we're going to use a quadratic formula. So we said that x equal to, this is b is equal to negative 1. So it's a 1, 2 negative become positive. And then b squared, so it's a negative 1 squared minus a 4ac. Okay. A is 1, C is also 1, and divide by 2a, 2 times 1. And that's equal to 1 plus minus, and this is just what? 1, looks like it's 1 subtract 4 over 2. So that's equal to 1 plus minus negative 3 over 2. Well, negative 3, okay, now here we know that negative 1 is equal to I, okay, so when you have negative 3, it's just equal to negative 1 times 3, it's just equal to I square root 3, okay, so we made this to be 1 plus minus I square root 3 over 2. And then now that is what we do for the part that for solve. Now to come back to go the other way, okay, put it back to the factor form, and this is an x here, okay, and then you go x, you go to other side, so that become, maybe I made this to be 1/2 plus minus I square root 3 over 2, okay, break it. So that become, you go back to the other side, okay? So 1/2 go to the other side, become negative 1/2, okay? And then plus minus, okay? Square root 3, oh, I forgot the I. I square root 3 over 2. And you want to continue, okay? If you want to continue, there's 2 of them here, okay? One is x minus 1/2 plus I square root 3 over 2. Another one is x minus 1/2 minus I square root 3 over 2. And if this is tough for you guys, don't even worry about it as long as you know how to solve here, okay? So this is the most important part. You're able to solve the solution. And this part, you guys, I know you couldn't ask me a question here, so you may have a little bit confusion. And then it just I break this one into two parts, okay? But if this is too hard for you guys, that's okay, okay? Just as long as you can able to do the first part. So that's for problem number 24. Now we're going to try another one. And the next problem is number 26. And number 26. And cube of x equal to x4 minus 625. Okay, and we're going to solve this one first. So it's the x of 4 minus 625 equals 0. Okay, see if you guys remember the formula for different 2 squared, where a squared minus b squared will give us a plus b times a minus b. And if you have 4 power, you just add another power there, okay? So make it to be x squared plus 25, x squared minus 25 equals 0, okay? And you can see in here, so x squared plus 25 equals 0, x squared minus 25 equals 0. And this one we can take it to the other side. So we have x squared equal to negative 25, x squared equal to 25. And you can see the I here again, okay? You can, because when I take the square root on both sides, so I take the square root on both sides here. Okay, I take the square root and take the square root. Don't forget the plus minus sign. And I do the same thing on this one too. And you can see here becomes negative 25. And that's the same as we know that when the I inside the square root, that's your, when you have negative 1 inside the square root, that's your I. Okay, that's your I. The I comes out, so I is equal to negative 1. And this is 5 here, so it's a plus minus I times 5, so 5i. Okay, and then this one's a no negative inside, so just x equal plus minus 5. Now they want to put in a factor form, and you just take it to the other side. Okay, so you have a x plus minus 5i, and this one's a x plus minus 5, and that's how you factor. Okay, so you just basically, because the plus go inside become minus, minus goes inside plus, so they all have a plus and minus. These are also a plus. Every time you say plus minus, you go to the other side also plus minus. Okay, so it's not that complicated, so don't think more than that. Just put plus minus. As long as they have plus minus here, and this side will have plus minus. So that's for number 26. And let's try one more on this part, number 32. The more we do, the better it will be, okay? We just need to practice. Number 32. We have cube of x equal to x of 4 plus 10x squared and plus 25. And we do the same thing. We're going to solve this one first. Equal 0. Okay. And we factor this. You can tell this is x squared plus 5, x squared plus 5. That right? So x is x squared plus 5 squared. Okay, now we set this equal to 0. And we don't need to worry about the square, just inside here, the x squared plus 5 equals 0. And when we subtract 5, that becomes x squared equal to negative 5. And we do the same thing again. We're going to square root on both sides. Don't forget the plus minus, okay? And then you can see that that will become x squared equal to plus minus negative 5. Well, we have the same situation again. We have a negativity here. Will come out, become I. Okay, so this comes out, it become I. So that becomes plus minus I square root of 5. Oh, I forgot to take away the x here. I'm sorry. Okay, I forgot to take away the square. So now putting the fact. So that's my solution. And you have the square here. You don't need to worry. They just repeat the solution. Now we're going to put it back in the factor form, okay? So for the factor form here, and we just put it back to x. So you have cube of x, if I write cube of x equal to x plus minus I square root of 5 and then square, okay? So that's all you need to do, okay? So that's for problem number 32. And the last number we're going to do is to learn how to go backward. If I give the solution, we go back to find this polynomial. So we did one of those in 3.3 last week, when we were still in school, okay? So now we're going to do problem number 40. This time they said find the polynomial, okay? Find polynomial. And if you are given, okay, the polynomial is a cube for x. It has a degree. The degree for this polynomial is going to be 3, 0, and I. Yeah, 3, 0, and I. And they said, this degree is a degree 3. I'm sorry, I forgot to write down. Degree 3 and 0, I. So this is 3 is the S on the top. So that's my mistake. Apologize for that. They said degree 3 polynomial, but they give us a 2 solution. Okay, this is x equals 0 and x equal to I. Well, where's the other solution? Okay, here's what happened. If you see the I here, a complex number, okay, you're going to have the conjugate of the same number come up. So the conjugate means that, like for instance, okay, a plus bi, the conjugate is a minus bi, okay. So the conjugate for I is just a negative I, so we need to put that in. Okay, put in the negative I, because they come out as a pair, okay? So you can see that now if you look at it, you have 1, 2, 3, you have 3 degree, 3 solution means a degree 3. Now that worked, okay? That matched what they said. So now you're going to go backward. You subtract 0 on both sides. Okay, that factor form. Subtract I, so it becomes plus I. Okay, now you add them all together, you multiply them all together, okay, that's equal to 0, that right? So now, because they are conjugate here, you multiply this one first, okay? Now here's the rule, okay? If you have 2 conjugate, x plus I times x minus I, and you come out as x squared minus I squared when you multiply by different 2 square formula. So I squared is equal to negative 1, so that becomes x squared minus 1. So that becomes x squared plus 1. So from now on, you see x minus I times x plus I, you will come out x squared plus 1. Okay? And then this x minus 0 just x. And then now multiply x inside, so x cubed plus x equal to 0, and that's your cube for x, okay? So your cube for x. So that's what they want to do. Okay. So this is some of the things you memorize is good for you. Make it faster. Okay. So that's for when you see x plus I times x minus I is always equal that. Okay. This one is always equal this. So that's for number 40. And now we're going to learn how to find all the solution. Okay, if I give you this one, can you find this for me? We're going to go the other way. And this is point number 15.4. Okay, we have here for x equal to 2x cubed minus ax squared plus 9x minus 9. So now we're going to solve this. Okay, so we're going to use the technique we learned in the last session and to see narrow down the solution first. Okay, list out the possible solutions. So we're going to use the p, q, and then p over q. So we're going to use this technique. So we want to find all the number can divide by 9. So it's a plus minus 1, plus minus 3, plus minus 9. So there are only 3 sets. All the number can divide by 2. So that's a plus minus 1, plus minus 2. Then p over q, that will be plus minus 1, plus minus this divided 1, this divided 1/2. This divides plus minus 3. Plus minus is 3 over 2, plus minus 9, plus minus 9 over 2. So what are these things? These are possible solutions. Possible, okay? They don't include all of them because they don't include anything that is a complex number or irrational number. Means a number that is square root, they won't include it. So they include some of the number here, so we don't know what they include. So we're going to use sincere division to check the answer, to check the solution. Okay, so we're going to go to -8, 9, and then -9. And to tell the truth, I tried it earlier, so I tried it. This one doesn't work, but this one works. 3. So I take down the number 2, okay? 2 times 3 equal to 6, -2. Add them together, I don't forget that's adding. This is 6, that's a 3, and you can see this is a 9. And then we get 0. Yeah, so this one works. So x equals 3 works. And the rest of it, this is a degree 3, that's a degree 2, so we have 2x squared minus a 2x plus 3 equals 0. Guess what? This one actually cannot be factored. Okay, so we're going to use a quadratic formula. So x equal to -b, so it's a negative and negative, so become positive. B squared, so it's a -2 squared minus a 4ac, so a is equal to 2, c is equal to 3, and then divide by 2 times 2. And we're going to simplify this one. So 2 plus minus. This is 4 minus 2 times 4 equals 8. 2 times 8 equals 24 over 4. Okay. So continue. So equal 2 plus minus -20 over 4. Well, we encounter negative inside the square root, so coming out is become I. So we have 2 plus minus I square root 20 over 4. Well, here's the problems. 20 comes out the root is 4 times. This is 4 times 5. So then when 4 can come out the root, become 2. So that become 2 plus minus 2I over 5 over 4. Now you can see that they have 2 here, okay, and there are 2 here, And we can factor that out. Okay, factor out the 2. So I'm going to continue here because it's too low here. So be 2 factor out. Once you factor out the 2, you only have 1 there. Okay, 1 plus minus 1i. So I don't need to write that. So it's I square root 5 over 4. Okay. And if you multiply, if you times by 2 inside here, you get back the same thing that when you started, okay? But why do I want to factor 2 out? Because I can reduce now, okay? So my final answer, okay, I'm going to put right here, the answer will be, 1, I don't need to write it. It will be 1 plus minus I square root 5 over 2. And then with these ones also answers, I put in front, okay, and that's my answer. So that's for point number 15.4. And the last point, I want to try one more, okay, is point number 15.6. We're going to try one more on this stuff. So hopefully more example you guys seen, then you'll feel better when you do your homework. So 15.6, and we have P of x equal x to the 4th minus the 2x cubed minus the 2x squared minus 2x and minus 3. So we're going to do the same thing. We have to solve this one. So we're going to list all our possible rational solution first. Means the solutions without I, without square root, we list them all out first. So P, Q, P over Q. And your P's, all the number can divide by 3. So the plus minus 1, plus minus 3. Q's, all the solution can divide by 1, so the plus minus 1. Divide them together, so plus minus 1, plus minus 3. Okay, so that means a possible solution without I or without square root, it will come from here. Okay, so we're going to use the sincere division to start to narrow them down. So narrow them down, any solution possible from here. So 1, negative 2, negative 2, negative 2, and then negative 3. And the first number I try is 1. 1 doesn't work, so I try negative 1. Okay, so 1, so negative 1, negative 3, 3, 1, negative 1, negative 3, and then 3. So 1, so this one works. And then I try negative 1 again, doesn't work. So then I try positive 3. And positive 3 works. So I kind of, you just narrow down, okay, if you try this one. So these are gone. So now you're going to try the last one. And so I go 1. 1 times 3 is 3. So that's a 0. 0, 1, and 3. And that's a 0. So this one works. So I know these two are solution. Now there's a more solution because of degree 4. That means I have a 4 solution, right? So other solution will come from here, okay? So x squared, because I have 2 already, so I have 2 left, plus 1 equals 0. And you guys can see this one we solved it before earlier. So x equal to x squared equal minus 1, square root on both sides. So x equal to plus minus square root negative 1. And you know that's just your I. So it's equal to plus minus I. So your solution comes out as negative 1, 3, and plus minus I. And you can see that the 4 solution, 1, 2, 3, 4. Okay? So that wraps up today's lesson. And be sure to do your homework.